guys, it's Mrs. Carter, and it's 8th grade science again, and today we're starting a brand new unit. It's the chemistry unit, and this is the first day, so let's talk about atoms. Let's start with our standard. This is the very first standard we're going to look at, and it is S8PS1. Students will develop models to describe the atomic composition of simple molecules and extended structures. So let's talk about atom. No, not atom, but atoms. We've got the plum pudding model, I like to call it the Jimmy Neutron model, but we'll talk more about this model, and the new electron cloud model that we think is right now. But we'll talk more about this later in the unit. Let's talk about the size and the scale. And we're going to start off by doing this with a video.
You probably already know that everything is made up of little tiny things called atoms. You might even know that each atom is made up of even smaller particles called protons, neutrons, and electrons. And you've probably heard that atoms are small. But I'll bet you haven't ever thought about how small atoms really are. Well, the answer is that they are really, really, really small. So you ask, just how small are atoms? Well, to understand this, let's ask this question. How many atoms are in a grapefruit? Well, let's assume that the grapefruit is made up of only nitrogen atoms, which isn't at all true, but there are nitrogen atoms in a grapefruit. Well, to help you visualize this, let's blow up each of the atoms to the size of a blueberry. And then how big would the grapefruit have to be? It would have to be the same size of, well, actually, the Earth. That's crazy. You mean to say that if I filled the Earth with blueberries, I would have the same number of nitrogen atoms as a grapefruit? That's right. So how big's the atom? That's really, 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 really small. And you know what? It gets even more crazy. Let's now look inside of each atom. That's the blueberry, right? What do you see there? In the center of the atom is something called the nucleus, which contains protons and neutrons. And on the outside, you'd see electrons. So how big is the nucleus? Well, if atoms are like blueberries in the Earth, how big would the nucleus be? You might remember the old pictures of the atom from your science class, where you saw this tiny dot on the page with an arrow pointing to the nucleus. Well, those pictures, well, they're not drawn to scale, so they're kind of wrong. So how big is the nucleus? So if you popped open the blueberry and were searching for the nucleus, you know what? It would be invisible. It's too small to see. Okay, let's blow up the atom, the blueberry, to the size of a house. So imagine a ball that is as tall as a 2-story house. Let's look for the nucleus in the center of the atom. And you know what? It would just barely be visible. So to get our minds wrapped around how big the nucleus is, we need to blow up the blueberry up to the size of a football stadium. So imagine a ball the size of a football stadium, and right smack dab in the center of the atom, you would find the nucleus. And you could see it. And it would be the size of a small marble.
Alright, so we get it. Atoms are tiny, and the nucleus is even tinier. So that's still really hard for me to grasp. So let's look at it this way. Let's look at the world to scale. So it's like the scale of our universe here. Let's let it load here. But what this is going to do is show you how tiny an atom is compared to more everyday things, like to us. Well, it's still loading. Alright. So here we are. We're humans. And let's go smaller. So, there's a human, there's a basketball, there's a shrew, which are a little smaller than mice and little tiny hummingbirds, and now there's a matchstick. So it's getting smaller. There's 1 square inch, so it's like the size of your thumbnail. It might be a little bigger, but about the size of your thumbnail and a penny. Smaller, sleet. Ants and sleet. Alright, so now we're getting on cells. That's the human egg cell. There's a skin cell and a white blood cell, which we know are tiny, tiny. Chloroplast, it's inside of plant cells. Mitochondria, an organelle inside of a cell. So we're smaller than cells, smaller than the viruses that make you sick, smaller than light wavelength, violet light. All right, so we've got more viruses, so getting smaller, so we're smaller. All right, the phospholipid bilayer here, this is what makes up the outside of your cell. So this is teeny parts, the DNA in the nucleus of your cell. X-ray waves, and we know we can't see any waves like that. Now, here's the water molecule, which is 3 atoms put together. Then the carbon atom, because it's a big atom. And then here we are at like the hydrogen and the helium atoms, some smaller atoms. This is your first atom we're going to talk about on the periodic table. So it's 10 to the negative 10.4. So let's slide back out again. And there you have it. We'll talk more about this in class. But click the link and go discover the universe for yourself. You can go all the way out and in. See you on Monday.